3.8 is on related rates. So let's take a look at what this means, what it says. So suppose that x and y are both functions of t. So we would have something like x equal to f of t and y equal to g of t. You can even rewrite that or write that as like x of t and y of t idea. Then when you do a derivative, we would say dx dt like that, and then or dy dt. And so those dx dt and dy dt are what we consider the rates of change of x or y with the respect, respectively, with respect to t. So if t is time, then it's like a rate. It's a rate of change. Could be a rate of change of volume, surface area, length, whatever it may be. So first, let's look at some basic examples, just taking derivatives implicitly with respect to t. So let x and y be functions of t not sure what happened there. And we say, like, this is the related idea, and related by, and then it might be a word problem or something like that. In this case, we're just going to do a polynomial. So it's related by x squared minus y cubed minus 2x plus 7y squared minus 2 equal to 0. I've made it somewhat simple because there's no x and y in the same term. Therefore, there's no product rule. Okay, so now differentiate both sides with respect to t. So we're going to differentiate both sides. You always got to do both sides. You can't just do one side. Both sides with respect to t. Because we're assuming that x and y are both functions of t. So it would be something like this. Let me just copy this and cheat a little bit. Save a little time. Okay, and then this one, we'll just erase that. So you're basically saying d dt of this whole thing. And then if there's something on the other side, you would write that, you put parentheses around it too. ddt of 0, of course, just 0. So you're doing basically, you can distribute the ddt across, so it's dx squared dt minus dy cubed dt minus 2 dx dt plus 7 dy squared dt equal to 0. So you would never really show that step. You just take the derivative. So this, what you get then is dx, or I'm sorry, 2x, and then you have to say dx dt because of the chain rule, minus 3y squared dy dt. Minus, and then that was just x, so it's just 2 times 1 times dx dt. Then it'll be a plus, and that'll be what, 14. Did I miss something in there? No, negative. Okay, then 14 y dy dt equal to 0. So that looks good. And there's really nothing else you can do. Oh, I almost missed that. This should be 0. I almost missed that. Well, I did miss that. All right, so there was a plus d dt of the negative 2. Okay, so that's going to be a plus 0 equals 0. So you really wouldn't need to write that because that is just 0. So you get the idea. So for now, you're just taking those derivatives. Okay, so try this one. So x and y are functions of t. Related by x cubed minus 2y squared plus 5x equal to 16. And then this one says if dx dt equals 4 when x equals 2 and y equals 1, find dy dt. So it's giving you information about the rest of them, and then you want to go and find it. Solve for that value after you do the derivative. So you must differentiate implicitly first. So always on a question like this or similar, differentiate implicitly with respect to t or whatever variable it is first before substitution. That's one of the biggest mistakes that happens is we start substituting variables or values into the variables before you differentiate. So now differentiate both sides, and we'll just write it this time. You get 3x squared dx dt minus 4y dy dt plus 5 dx dt equal to 0. And then substitute and solve. So we have 3 times 2 squared, and then dx dt was what? 4 minus 4 times y, which is 1, and then that's what we're looking for is dy dt, plus 5 times dx dt, which was given to be 4, equals 0. So you're substituting in everything like that and then solving. So you get 4 times 4 times 3 is 48. Oh wait, that was negative 1. Y was supposed to be negative 1 in my original question. I don't want to change it. Change my notes all around. So that's supposed to be negative 1. So it's a plus 4 dy dt. And then we'll say it equals negative 20. And then you solve. So you continue to solve. And we get 4 dy dt equals, and then negative 48 and negative 20 is negative 68. And then you reduce or simplify, whatever, either way. And you get dy dt is negative 68 over 4, which you will find out it goes into it real nicely. It's 17. So the answer to the question, dy dt is equal to negative 17 when dx dt is 4, x is 2, and y is -1. So that's the related part. That's how they're all related together in some way. So now let's look at a question, and I'm just going to copy the question over and save us some time. If I could find it. There it is. Okay, and I won't do the write-up yet, but here's the question. Then I'll draw everything else and do all that. Okay. So here's the next example. Not sure why I put it all the way down there. Just put it right there. So let me read it out loud. A ladder 20 feet long leans against a building, and we'll draw that picture. If the bottom slides away at a rate of 2 feet per second, how fast is the ladder sliding down the building when the top is 12 feet above the ground? All right, so you need to draw some sort of diagram, some sort of depiction of this, what's going on. So we have a wall. It'll stop actually. And then you have the ground. And our ladder is 20 feet long. So we just kind of go in here and draw a ladder 20 feet long. Close enough. So that's 20 feet. Big ladder. And then so that is your X value. This is your Y value. You can start labeling stuff. So, and so this was the wall. So ladder 20 feet long leans against the building. Okay, leaning against the building. If the bottom slides away, so we're looking at the bottom sliding away like this. So the bottom sliding away like that. That means the top, of course, is coming down, right? I mean, you're going down then like this. Slides away at a rate of 2 feet per second. How fast is the ladder sliding down the building? So this is how fast is the speed. So over here is the question mark. When the top ladder is 12 feet above the ground. So at some point we need to substitute in a value up here, this 12 feet. So let's write down some information we know. Well, we know that we have a Pythagorean theorem situation. X squared plus y squared is equal to 20 squared. We have that. We have the bottom slides away at a rate of 2 feet per second. So we can say dx dt is a rate of 2 feet per second. We may need it to be negative, but for now, let's just say it's that. So we're looking for dy dt. Dy dt is equal to what when y is equal to 12 feet, right? That's this distance here. So let's see. So that's this distance, 12 feet high. So we don't know. So what we're going to do is sometimes you need more information, sometimes you don't. We're going to differentiate both sides. Now, before we continue, given this equation, we can find another variable. We can find x when y is equal to 12. Because we have that equation. So we have this equation. So that's what we're going to do. So x squared plus 12 squared is equal to 20 squared. So x squared is equal to 20 squared minus 12 squared. So that's going to be, what, 400 minus 144, something like that. So it's 256, do the calculation. So x is, of course, just positive, is 16 feet. Okay, so we have all the information we need to substitute in. What we're going to do next is we're going to, without substituting the values, we differentiate both sides. Okay, so differentiate both sides of that given equation, or the equation we made up, I should say, with respect to t. So you get 2x dx dt plus 2y dy dt equal to 0. Because, right, d derivative of 400 is 0, right? It's constant. So now you substitute the variables above, so from above, and solve. So you can solve directly if you want, or simplify. I mean, basically, I'm going to simplify a little bit first. So you can rewrite this as 2 dx dt, because you can just divide out by 2, plus y dy dt equal to 0. And we're solving for dy dt, so you really can just simplify this. Let's just go this way. Save a little room. So you end up getting y dy dt equal to negative x dx dt. And then one more step, you got it solved for dy dt. So dy dt is what we're looking for. I should have said that earlier, sorry. What are we looking for? We're looking for dy dt. The rate of change of the ladder as it comes down, right? We're looking for that rate of change. So that's dy dt. So that's what we're trying to find. And it's not up here, right? So dy dt, so that was right here. I actually did say, yay, right there. That's what you need to find. You're looking for dy dt. Okay, what is that? So I've solved for it. You can substitute and solve. I went ahead and just solved this simple equation, and you get negative x over y, and then dx dt. And then now substitute in, and you get negative 8/3 feet per second. And it makes sense, it's going down, so it's negative. You can always adjust that later if you need to. All right, so next we'll talk about guidelines, and then start doing a bunch of problems and examples to try to figure this stuff out. And we will definitely try to do this a couple times in groups, either in class or problem sessions or whatever it may be.